Hello. Okay. Good afternoon. I am Rudy El-Khoury, Dean of the School of Architecture. Delighted to welcome you here today, to welcome you to our third annual Smart Cities Miami Conference, jointly hosted by the School of Architecture and the Center for Computational Science. The Center for Computational Science, we call it CCS, is a university-wide platform for research and services led by Dr. Nick Tinoremas. You will hear more from him this afternoon. And powered by advanced computation and digital technology. By the way, it is the home of our supercomputer, Pegasus. Focus areas at the center include climate and environmental hazards, computational biology and bioinformatics, data visualization, and, of course, smart cities, the area where the School of Architecture and CCS converge and collaborate on a number of exciting projects. These include, just to mention a few, the mapping of informal settlements with the use of drones and photogrammetry, actually a photogrammetry with a CCS twist, proprietary technology that is unrivaled in its economy and efficiency. We have various tests, experiments with ubiquitous sensors, including one in Miami Beach using new methods and technology for sensing and data analytics. Zen City is a smart city designed from the ground up in the Yucatan province. Some of its innovative features include customizable municipal amenities that the users can adjust using an online digital platform. We have automated public transportation system inspired by high-rise smart elevators, and a variety of public infrastructures for renewable energy. And we have the Zen City team here with us today, ready for the next phase in our partnership to take this project even further. These and other initiatives, including cutting-edge research on smart infrastructure at the College of Engineering, and projects in embedded technology at RAD, a lab at the School of Architecture dedicated to the Internet of Things. These projects position UM in the vanguard of the smart city field and compels us to sustain with the annual conference a public forum exploring the future of cities. So the conference isn't strictly an academic forum. Smart Cities Miami, as indicated by the title, is about smart cities, the smart city phenomenon in our city. The real world, in real world application and in partnerships with local government and industry. This is a forum for the larger community, entrepreneurs and innovators that are reinventing Miami as an incubator for tech startups, development and planning agencies in the public and private sectors that are guiding the evolution of one of the fastest growing cities in North America. We are interested in this public forum because we believe that we are at the threshold of significant transformations in the urban environment provoked by new services and practices driven by emerging technology. We are witnessing now the disruptive power of the likes of Uber, Airbnb, etc. But wait until the self-driving car is here, along with other radical disruptions that are sure to change the ways we imagine, inhabit, use, enjoy, manage, and govern our cities. I'm thinking in particular of the new platform for spatial computing introduced by Magic Leap, South Florida's most talked about tech startup. Ronnie Abowitz, Magic Leap's CEO, is here with us today to tell us more about it. But Before we move on to this much anticipated presentation, I would like to thank our participating sponsors, Build Sumberg, IBM, the City of Coral Gables, and Zen City. Their generosity and vision have allowed the University of Miami School of Architecture and the Center for Computational Science to lead in this exciting and ever-evolving journey. And now, please welcome Provost Jeff Dirk, who has the honor of introducing our keynote speaker.
I too would like to welcome you here to the Smart Cities Conference, and I'm really honored to introduce our keynote speaker at this third annual Smart Cities Miami Conference. As we just heard, Ronnie Abovitz is the founder, president, and CEO of Magic Leap, based here in South Florida. And I think many of you have heard that Magic Leap is a technology company that has already raised billions of dollars in startup funds from companies like Google here in the United States and the Alibaba Group, and has partnerships with companies like AT&T and Home Depot and others, and media companies around the world. What you may not know is that Ronnie is born to Israeli immigrants and raised here in Broward County, and he was fascinated with computers and science at his youth, and as a young person, he wanted to be an artist, a scientist, a musician, an engineer, and I think you'll see that he has achieved all of those things. He has a BS in mechanical engineering and an MS in biomedical engineering from here at the University of Miami, and so we're pleased that he's not only one of our alumnus, but while he was here, he was not only a cartoonist and columnist for the Miami Hurricane, the campus newspaper, but he was a DJ for the radio station on the varsity track and field teams. So even in those days, he was a scientist, an artist, and an engineer. After leaving UM, he co-founded his first company, ZCAT Incorporated, a medical technology venture that revolutionized minimally invasive robotic surgery. And I think many of you may have already benefited from that technology as it exists today. I know I have, for example. Twice named a technology pioneer by the World Economic Forum, ZCAT spun off in 2004 to Mako Surgical Corp., which focused on haptic and touch robotic surgery for minimally invasive knee operations. I myself am going to have one on Monday. By the time Mako was sold in 2003 to Stryker Corporation, a medical device manufacturer, for $1.65 billion, the company had already grown to over 500 employees and more than $100 million in annual sales. And it was really one of the very first, if not the first, haptic robotic minimally invasive surgery devices. At Mako, Ronnie planted the original seeds for what we now know as Magic Leap, really in his spare time. In his spare time, he also created a graphic novel and feature film called The Hour Blue, and this alien planet was populated with talking robots, flying whales, and other imaginary creatures, some of which, if you've seen the Magic Leap technology, are part of the inspiration that the company uses to get all of us to think about technology and its applications in different ways. He sought the help of Weta Workshop, a New Zealand-based special effects shop best known for its work in The Lord of Rings, to really imagine not special effects, but really what computing should look and feel like. It shouldn't be a device, it should be an experience that we can all relate to, and really think about how we would bring computing to life. So it's my pleasure to introduce our alumnus, a pioneer here in South Florida, a venture capital, an inventor, Ronnie Abovitz.
I'd like to thank the Provost, Dean of Architecture, Dean of Engineering, and the President, and all of you for being here today. It's definitely a humbling thing. So my background, mechanical and biomedical engineering, so my only claim to architecture is that my uncle's an architect. What I'm going to talk about is a bit about what we do at Magic Leap Spatial Computing, which I think is a broad field that's going to cut through most aspects of life, and how we see that applying to cities and daily life, which I think could be relevant to this conference. A little bit about what we do at Magic Leap and what is spatial computing and how it's relevant to smart cities. So we're a spatial computing company. It took us a little bit of time to try to coin what we were and what we were not, and I'll define that a little better. And a core part of our mission is to harmonize people and technology together to unite and to make things better. And I think it's a really important part. We really want to focus on people, and I think anything to do with smart cities, when you look at technologies that could displace people, disrupt life, you have to think carefully about it. I think someone mentioned Uber and Airbnb and how those things are disruptive forces. Having some foresight, and one of the things we did was we partnered with the University of Miami on Project Alexandria, a campus-wide project, to think as a campus petri dish about these disruptive forces before you unleash them in the world en masse. And I think the campus is a great place to do that. You can sort of understand social disruptions, how to mitigate them, maybe a little better before you just unleash them in the world and then things just happen. We're all the recipients of lack of foresight sometimes. If you go back 100 years, everyone thought technology was just good. You just do good technology and good things happen. Not always true. So I think when you're designing smart cities, you want to keep that in mind about, is this going to help people? So our focus is always people in the center and surround them with technology. So part of what we do, and I think part of your thinking would be wonderful to incorporate into design, is that how do you amplify somebody? How do you amplify the world around them? How do you amplify your capabilities and intelligence? Which is, I think of that as like Tony Starking somebody. And you know, not the suit, you know, not the flying, maybe some of the flying at some point, but the idea that you've got this amplified intelligence which is binding the power of computing and data and AI around you, and imagine that citizens all over cities and things in cities will have sentience and awareness and intelligence. They're not just going to be static things anymore. They're going to almost be alive like nature is. Sort of the convergence that we're in today, I'm going to give you a little bit of our thoughts at where these things come from. So one side you have like telecommunications, you know, go back to like the late 1800s, Alexander Graham Bell, and you see the evolution of computing and communication like in parallel. You have like these things converge like in mobile computing in some way. You have both the ability to be mobile and you've got computing and you've got networks, so it's starting to come together. But what we think is a really interesting inflection point is the convergence of spatial computing and the emergence of like 5G. And what I mean by 5G is you can imagine like cities in particular, because it's very city oriented versus like suburb or like field oriented. You're going to have like edge computing, very low latency, massive amount of data with the ability to surge up and down data and computing. And it's going to be very city-like. So if you live outside these like new future cities, it's going to be like living in Kansas and then you go to Oz. And the convergence of spatial plus 5G and everything 5G and very low latency, super intense computing can provide is a whole new set of things that we're going to talk a little bit about today. So in our company, we break down, at least we think for the next 10, 15 years, what we see are 4 fundamental platforms. And the things, we see these fundamental platforms will tie into lots of things like IoT and other components, but these are the platforms we're working on that could be tools to be used in designing smart cities. The personal side is what we think of as sensory field computing. So to break down sensory field, we're in an academic place, it could be a little geeky. We think about light field physics, so the physics of light fields and how that interacts very specifically with your eye-brain system. So I come from a biomed background. How do you send a signal that respects how the eye-brain system works? Which means everything from like diopter mismatch being minimized to the frequency of light and adjusting the colors, warmer and cooler during different times of day, and human biorhythms, sound fields. So how do you have natural sound field? How do you have touch? So you can like touch digital objects. And really impedance match the human sensory input system is a good way to think of it. So you've got your whole brain is just a big sensory input system with processing and memory and all kinds of interesting things. But if you think of it as a big sensory computer, computers should become matched to that. And we think of that whole field as sensory field computing. And that's what we're doing with our first systems and beyond. So instead of you bending to a computer, computers should just fit how people are, how we are biologically in all ways. What we think of as a life stream is, I think, really important in smart city design. If you imagine 2 kinds of life stream, an analog and a digital, and I'll just go through it kind of quickly. If you could like capture every single thing you experienced, your experience path from the moment you're born through the moment you die, and everything externally as you move through life in that experience path. So it's like a space-time, almost like quantum physics path you're going through, but also your internal memory state. And if you could fully capture that, that would be like our mathematical definition of an analog life stream. The digital thing is what our sensors can capture. So we capture a portion of that, but the relevance of that could be incredibly important, like health biometrics, awareness, patterns of life. If you imagine a campus, like, you could see students moving and play that back. So we've done things where you can like walk around a space and then see yourself walking around that space later as a volumetric presence. And life streams is a term we use to think about this like massive, both internal emotional state plus external data state. And if you think about life streams on top of cities, it would tell you almost everything you need to know, whether they're captured by the personal devices or the sensors. It also brings incredibly important questions about privacy and security, and our view is that the life stream should be owned by the person who creates it. It's like your personal copyright. So you should fully own that, and you should have basically blockchain type valves that open and close, that allow you to share or not share. So you never give your data to anyone, you give them permission temporarily for a purpose, and then you kick them out. And until quantum computing comes up, I know somewhere at someone's working about that, there's probably blockchain and biometrics, which are multifactorial, that provide a lot of security on this. And then when quantum computing comes up, that's why we have Project Alexandria, because we have to figure out how do you stop that. So quantum computing will probably crack through all the different blocks you could put today. So it is something to think about. Like, you can operate probably with a good feeling of privacy with multifactorial, biometric, blockchain kind of things tied to your personal data. But then when you've got quantum, it's going to get interesting. Human-centered AI is a really important part, especially for us, where we want to bind the power of AI, which is this like force pushing through everything. I think it'll be a super relevant force in all future city designs, but amplify people with that. So a very simple way of thinking about human-centered AI, if I was playing chess with Garry Kasparov, but through my system, I could query Deep Blue and Watson and any other like AI system, and I'm just sitting there wearing what looks like this, and we're having a chess match on an analog chessboard, I will beat him all the time, because me plus the AI will always beat Garry Kasparov. So think about you as a person having access to a massive amount of intelligence and data, what that could mean. So in a city, imagine like the whole city of Miami had its own AI. We call that notion Oz. Like the city has its own AI, and it could tell you and everyone else what you need to know about Miami. And if you're a construction worker, it might tell you where you need to dig, because, oh, there's a pipe there, don't cut that. So the city itself should have an intelligence that could also help people within that city. And the last thing, we coined something called a magic verse, which is heart of the project we're doing with University of Miami, which is a total set. It's almost like the sum of the first three. So imagine a population of like 1 million people with sensory field computing, with IoT in the city and infrastructure and drones and smart cars, like the total system. And how do you build that system, and how do you operate that system, and how does it all work together? So we're not building all of that. We're building components to plug into many other components. And some of those things are physical architecture. Some of those things are IoT companies and wiring systems and city planning. But the idea is, can you govern and operate things quite differently? So we'll spend most of the time talking about magic verse-like stuff here, because it's the sum of the first three. But one of the first things, it's like, think of it as a system of systems. So we're looking at city design as like total system engineering level and total simulation model level of all things that are happening. And how many of these like static and dynamic data points can you grab? And how do you model that? What kind of computing does it sit on? And could it be core and centralized and protected in some way, so that the people that have to govern the city and people who live in the city have some balanced way of interacting and taking care of all these services? So we see it as like, there's individual human life streams, but cities will generate life streams. You should be able to query the life stream of Miami at some point and understand its patterns of life across the total city, like at 2 a.m. on Saturday, what's going on, all over the place. And you also have to decide, I would say, in an open Western democratic society, what should you not gather? So I think that's a really important topic for smart city design in open Western democratic countries. What data should you not get? What data do you need to get? What's the line between security, knowing that someone's about to get mugged? You might be able to know that with a certain amount of data intelligence, but how far do you want to go before you turn into Minority Report? These are questions for a group like this, and questions to be answered in Project Alexandria. We also see many system layers. And one of the key things is if these layers don't talk, if they're not harmonized, you just have a bunch of disparate stuff. So part of our goal in proposing a notion like a magic verse is that you should have a harmonized city design and planning, not just the physical part, but all the digital parts, including a digital clone of the physical city. So the physical city we think of as a Singleton. There is one physical Miami, and there should be one bona fide, legitimate, certified digital copy of the city of Miami to the highest degree of fidelity, or one high-fidelity digital model of the University of Miami. And then from that, you could springboard all these other layers, like the transportation layer, the energy and water layers, healthcare layers, education, communication infrastructures, entertainment. You could have almost an infinite amount of personalized layers. You could have, so each person can have their own view and access their own components, but there should be like certified, authentic, this is the current state of affairs digitally, because there's like one exact copy of that physical thing. So maintaining that's a really interesting problem. But if you have that physical Singleton, it's the springboard for all these other digital services. One of the things we're working on proposing is like a kind of city-scale operating system to interlink the digital and physical, including creating like what is the AI of that city, digital singletons of people as they move through the city. So you might project an avatar. You might be in Paris, but project your avatar persona into the city of Miami. You might be walking around in a shop or having a meeting. Or you might project your avatar AI to go do something for you. And you might be projected in 10 cities at once. So the idea of having the digital replicants that have either direction or semi-autonomy becomes really interesting. And it's not stuff that's theoretical. It's actually stuff we're starting to do today. At CES a couple weeks ago, we had someone sitting at a table playing chess with a live digital presence avatar. It was very Kingsman, if you saw that movie, where they have the scene, they put on the glasses, everyone appears. It was pretty much that. So the notion of like a binding core OS for a city that ties all these disparate layers of services together, that ties to the architecture and the sensing, and I would say almost aliveness of stuff, like do buildings need to be sensed and alive? What's happening with the roads, the people and patterns of life? But does a rock sitting in an empty field, does it need to be sensed? The reality is once someone looks at it, it is sensed and captured, and then you could segment it and give it all kinds of metadata. That rock might be a waypoint for 2 students who leave secret notes there. And to you, it's a rock, but to them, it's an entire story, and digital flowers are growing out of it. So every object is potentially something that has relevance within a magic verse, beyond its known physicality. So we see this continuous cycle between what I'd say is the physical side, the persistent virtual and digital side, and like the simulation of different destinations. So there may be a Miami, and there may be portals in Miami that go beyond the physicality of Miami, which sounds, President Frank talked about the paradox of the power of place last fall, and the idea is that Miami has a really strong power of place, but you can give it portals so that you can look through that portal and see Berlin and Paris and maybe other countries, and those things could be embedded into the city of Miami. There could be a park that gives you portals to other parks around the world. There could be a park in Miami where if you walk in a similar park in London, you are now hanging out together. You are sitting on the same, there's a physical bench in Miami, you sit down, someone in London is sitting down, you see their physical digital twin and they see yours. So it's actually an interesting way of connecting other places and their power digitally, which adds a lot more amplification to what's possible within the physical domain of a city. A couple attributes of what we think of as spatial computing and magic verse, and I think they're different from normal computing attributes. And they, we've been testing, it seems to be holding up. So I'll start with spatial computing. One of them is presence. The digital world, and this is something Dean Bardette and I were talking about earlier today, the digital world is hidden and unseen except when you pick up a phone or a laptop and you get little glimpses into it. Giving full presence to data all around you, to information experiences, it's like a Miyazaki movie where suddenly revealing the spirit world. So things could have scale, they're there, like we're all physically here, we're all present. I'm not a video screen. It's very different when you have real presence. There's something the human brain relates to true presence. And presence relates to how the visual cortex processes light field signals and sound field signals and touch. We take these inputs of sensory field to create a sense of presence neurologically. So Our computing and spatial computing is about recreating digitally the neurologic sense of presence and awareness. And that means you have to impedance match those signals into the brain to recreate that feeling that we all have right now. Scale is very important. Like, my phone is like 4 or 5 inch screen, but if I want to have a 40-foot building or a 300-foot building or a 50-story building or giant things, I can't really do that. I can have a wonderful CAD model trapped in my laptop, but if I want to go put that on a field and see what that's like full scale before I build it, I need real scale digitally. I have to take it out of that screen, put it out in the world. Awareness is really interesting, in particular for smart cities. You need sensing to understand what's happening and to be smart and aware. Our systems are aware of you and the environment simultaneously. And they will want to talk to objects that are aware of you and themselves simultaneously. So that's where this idea of like smart cities might become more like nature. If you're walking through the woods, everything is alive. The trees are somewhat aware of you, and animals are somewhat aware. So imagine physicality has awareness, and that's what software with spatial computing and also sensing really can do. And then you can add things like interactivity. Interactivity just doesn't mean a button. Like on our system, moving, breathing, your eye dilation, your heartbeat are all inputs into software. So really subtle, massively multi-input computing is relevant in spatial, and you have to think about what would the relevant IoT sensors be like. They could be much more subtle and sensitive than like just a switch on and off. And then how do you program things like that? Because it's not just, you know, multi-touch or I have a mouse and keyboard. You have these really interesting problems of like I/O when you have massive inputs. But that's much more like the real world. Respect is something that's non-technical, but we've inserted into spatial computing. Respect for design for human biology, respect for privacy, and respect for sociology. I think when you think at a city scale, you really have to think, how do you respect the governance and all the population of that city? You can imagine in some countries that are operated differently, non-democratic, you can have a huge disrespect for the population, and it becomes like a fascist central control nightmare. That's not what you want to do here. You want one where it's decentralized, you give as much power to the population, minimal central governance, you know, for core utilities and safety functions. So I think that architecture of respect and governance is super important, I'd say, for, you know, modern democratic countries, as opposed to the total misuse of this kind of technology that you might see in other countries one day. And it's a scary thing because it's got both really good and really bad potential. So hopefully at and here you can find the good parts and maybe try to suppress what could be negative from it. Really quickly, sentience, AI. Imagine your buildings, your cars, digital objects are not just simple, responsive things that are aware, have I/O, but are truly sentient. I mean, you could have like multi-hour conversations. They have professor-level IQ in a few years, and they might have in 10 years IQ beyond all human capabilities. So how do you involve sentience in a smart city? And when the city AI itself will be sentient, you know, what we call at Magic Leap and Oz, what does that mean? And how do you talk to the city of Miami one day when you have an AI that can know all things about Miami and what you need from it? So trying to make the argument that spatial computing is one of the major transformation functions on modern cities, and it's partially because there's infrastructure going to get built by giant telecommunication companies who are putting 5G in all the major cities in the United States and around the world. 19, 20, 21, 22, you're going to start to see this all over the modern world and in Asia. And then when you build on top of that, it sort of will become this like Renaissance age for smart city. And then if you insert spatial computing and AI into that, you have this whole new toolbox that can completely change the thoughts on architecture and design, which is why this is exciting. If you're a student right now, it'd be super cool. Some pillars of livability, we've been involved in some like really crazy futuristic Epcot-like city design projects at Magic Leap. Just sort of give you a quick rundown. I think like you know, quality of the residential life is one factor to think about. What's your access to amenities? What are the amenities in that city? How do you connect with people? What's the quality of government interaction? Again, you know, how do you maintain an open, democratic, you know, non-centralized, non-fascist way of life? Really important thing to think about in the design of stuff like this. Safety functions, health safety, police, fire. And it's one of these things where you over-rotate and you make it super safe, but then you've lost all privacy and personal freedom. So you have to think about those balances. Quality of the environment, to be able to sense, like if you've got pollution, or maybe pollution you can't see, you can actually visualize that and say this part of the city has some toxic gas, avoid it, and everyone is routed somewhere else. What's the mobility? Drones, autonomous vehicles, how do you summon them? How do you have those things in a hybrid world not collide with people who are still riding bikes or driving their own cars? Education can be incredibly powerful. We're going to have a couple quick storyboards on that. Healthcare, super powerful. Imagine you're walking through Central Park, you have a spatial computing system on, and the system detects 5 minutes before you have a stroke that you're going to have a stroke. It picks up a small change in pulse, a little change in breathing, a little bit of eye dilation that have been machine-learned precursors to stroke, and it looks at your age and weight and everything else and says, oh, you're about to have a stroke. Summons a drone, summons a self-driving ambulance, and scans people around and goes, there's a doctor 50 yards away who's just having lunch with his kids. Summons that doctor, points an arrow right at the person, and you catch them before the stroke happened. Those are the interesting good things that could come if you converge all these different elements within like a future smart city, what we call a magic verse. How do you make quality of work better for people? So it's like not coal mining, but more creative, more intelligence-based work. What is the entertainment value, and what are the social norms in these kind of worlds? So I think there's a lot of real interesting pieces. And then like fundamental security. How do you make something safe? You could design a crime-free place because you're so super censored. As someone's approaching to mug you or rob you or break in, that's always known and all kinds of ways to prevent that. But is it an overly controlled world, and is it no longer something that you want to live on? So again, a great Project Alexandria question for students. How safe do you want to be on campus? Somebody wanders in from off the street, does the AI want to know that? So this is, I'm just going to show you a couple storyboards of how we are think about applying, and some projects where we are applying these things. So here's maybe some of you sitting on the 17th floor, and here's some future parts of, let's say, some Neo Miami getting constructed, and you're looking at the physical infrastructure not built yet. And this is the underlying, think of it as the mesh, but I would, almost like the matrix, but think of that mesh as not just static, but having dynamically updatable elements and elements that have metadata and sort of information quality that can change over time. So it's not just a static thing. Whoops. Go back one. So now you're looking at one building, and what's really interesting is go to that site and now see your design at scale. Walk into your design at scale. And just as an architect, that could be profoundly interesting, because a lot of people cannot really relate spatially what they're doing on screen to the site. Now, if you can, you're a master architect, you're probably the dean, you probably have that brain function. Most people don't. Most people have something here, and they're trying to correlate it to something in space and scale, and it makes no sense. You could do a lot of interesting tests with almost no cost, put your whole building. Imagine every architecture student could just design a 20-story building, put an empty lot, and you walk around your building. Or I designed a space like this, and I'm just in an empty field, fill it with people. I'm able to understand what all this looks like. I'm like, oh, move the podium over here. So you could do some of that in VR today, some of that in simulation, some of that in model building. But we think there's something powerful, like I'm at the site, I'm at the physical thing, I've got part of the rig there, and I've dropped this digital model, and it's full scale. And now what you're able to do is add other metadata components. It could be, I'm not just interested in the architecture, but what are the persistent digital parts of this building that are going to be there? Because as a digital physical architect or planner, it's no longer just the bricks, but you may design digital things that are extensions of that building that you don't have to build physically. And they may be there for 100 years, and that becomes really interesting. And now I'm looking at a different layer. This might be like an information or security layer across the entire city, and now you're going, that is just like designing a physical building, you have to put those things in space. So now you get to see across like the whole city of Miami, all these different permanent digital structures that are living in space, tied geospatially to something. I may be looking at traffic patterns around new sites, and because I've got the pattern of life of what the highway was doing, I might be watching a real-time simulation on I-95 of that traffic next to my new building, and I might have like hundreds of people who are digital simulation AIs wandering around the real place, interacting with stuff. So there's something about being in that physical thing and doing it there, which adds like maybe that next step of accuracy and understanding what you're designing. And this might be looking at, let's say, the wind patterns, or what happens if a hurricane comes. So imagine you're designing a building and you have a hurricane sim from the environmental engineering department, and you see incoming waves, you see a Category 5, and you watch that wreck your new design city, and then you go, oh, let's change the aerodynamics in real time. So you're incorporating a lot of disparate functions, like something happens in a wind tunnel here and someone's computer over there, all at once, which means you need immense computing power. What's really cool, though, is immense computing power is actually coming really fast. When you think about a 5G city, you're going to have like edge computing, which could do a lot of like local buffer computing at super low latency, and then you'll query through fiber some supercomputing that you might have on campus or nearby. So you might be able to do some of these things in real time or near real time in the place. So a couple of quick use cases, really fast. This is an urban planning scenario. So in the sketches here, everything black and white is physical, and then all the colorful elements are digital. So what you have here is a bunch of people working, and then their colleagues have co-presenced in. They could be, let's say this is at and you've got a colleague from Berlin, from London, from Beirut, from anywhere in the world. And now they're designing that city we were wandering in, and you just sort of see tabletop, like you might have physical architectural models all just appear, and you're looking at all the layers. What's interesting here is you got physical people looking at a digital model they can change with colleagues who are digitally present from other parts of the world. And now in that same lab, you've blown the roof off and put like a third scale model of that. So you go, let me see what that's like in scale. So you're now easily expanded a model. This might take you, if you're an architecture student, 8 months to build. Digitally, it just took half a second to scale the thing up. And now you might have blown another part of the wall. What I mean by blown part of the wall is just erase its physical light field signal and impose your digital light field signal. And you're not looking at a flat monitor. You're looking at a spatial hole in the wall that shows you, like Miami, from your little lab. So you're looking at a volumetric, multi-view, full-scale portion of the city you're designing. So as you're tweaking the tabletop, the third scale model's changing, and also the view through the wall's changing. And you've got co-presence friends. Now you might be in the governance committee, and this is like sitting around looking at the whole city and its operations, and this might be your future command center, which is, I don't have a great metaphor, but it's like very Hunger Games-esque, I guess, without all the violence. But you can imagine, like, you need some place, which I think of as the command center, to see everything together. A lot of cities right now have this like giant NASA-like wall of monitors. One of the things we're proposing is that, it wouldn't be great to have like just a scale model of that city. You could scale up or down and just look at it and see everything happening in real time. And we've already built, first test simulations of this, which is really cool. Education, very relevant to being on campus. Very similar, you've got a bunch of students in a lab, again, co-presence. In a situation like this, half of you could be co-present from other universities in a talk like this. You've taken like the lecture hall and you've blown out portions of the windows and you're looking at some urban planning project. And what they're doing here is they're designing simulations of AIs and robots that are going to do some kind of farming activity. And then they see on the tabletop, this is the whole landscape they're working on together. But now they're out, they go off the city, they're in that urban farmland, and what's really interesting here is their co-presence fence can also appear. And full-scale versions of the things they were designing appear in the places that you'd want to build them in some kind of like, future farm agriculture design project. And including your AI, which is a little AI robot that has no mass, but it still functions with all the AI sentience and is aware of what's going on. And you have this physical robot digital model, which might become a physical robot one day. And now you're taking your simulations and putting them in place before you might do a dig. And then you might have like, drones passing, which could be for camera irrigation, and like you could have like farming equipment. So you're running your home model of this like, agricultural urban planning thing you're doing without any real physical cost yet. It's almost all digital with a few physical people. And then running that test in the place gives you a real sense of what could happen. This one's actually kind of interesting because it's pretty much what we're doing right now. So if I had a friend, let's say I had a friend from Stanford or MIT, he might or she might just appear and be a co-lecturer, and other students might just appear. So if you had our spatial computing system on, and you look to the left and the right, there would be a room full of people just like you who are co-present. They might be sitting in another lecture hall like this, and you would be digital to them. What's really interesting is like how you can amplify a space by giving access to people who have like co-equal presence, but they just don't have atoms. And it means they could transport themselves really easily and quickly. And we are doing things like this right now, and it's actually quite amazing. I gave a talk in San Francisco. I was on stage with a friend of mine from Twilio. I was co-present as an avatar. I was in my office, but I was also on stage at the same time. It was a very weird, literally out-of-body kind of experience, but we're at the very beginning of that happening, and it's just like the first telephone calls. Like, now we don't think about it. So at some point, you know, hopefully within the next decade, this will just be a no-brainer. Like every lecture at UM will be something like this. What's neat here is I could bring other elements outside of like PowerPoints into things like this, where I'm bringing full scale. Let's say we're talking about like DNA and botany. I'm like blowing out the back wall and I'm showing the farmland, we're showing full scale objects, and everyone suddenly has those objects sitting in front of them. So what professors will be able to do and lecturers will be able to do could be kind of interesting, because you could give personal access to a student to something, and then you can also do things at scale. A little quick thing on transportation. I know it's a topic. What do autonomous vehicles do, and how do they coexist? So here's something with autonomous vehicles and drones in some future city. And what you're seeing here is, like, for pedestrians, you might have continuously variable like signage that is a function of what's going on right now. So this means that enough spatial computing systems and enough IoT sensors are working together in sort of a grid kind of network to say, given what's happening right now, you can go, this car's going that way, this drone is here. So it's a dynamic situation. Like you think about stop signs today, they're very simplistic and static. In these future cities with all these autonomous things, the idea of having dynamically variable information and signage could be incredibly important to keep people safe. You might see the drone pathway. So for some reason, you might be the person in charge of like making sure the delivery drones don't crash into stuff. So you can understand, you know, their highway and walk through the city. And if you're a planner, you might be able to change that highway by moving up or down, depending on different times of day, if you're building something. Here's a person going into an autonomous vehicle, and the digital people who appeared are members of her team, and they're going to have a conference inside that autonomous vehicle. So here she is being driven somewhere. Looks like they're playing D&D. I don't know what they're doing, but she's in the vehicle, but you got two co-presence friends in an autonomous vehicle, and they're having a meeting. So you think about, like, what am I going to do when something is driving me around? Am I creating a conference room? Am I having functional meetings? And in this case, we're proposing like that starts as she's walking into the device. So the vehicle knew that she had a meeting. The system knows where she is. She walks in, and her co-presence friends appear. Conference call scheduled. You got 20 minutes. So that became like something like a face-to-face physical meeting in an autonomous vehicle. This person is playing a Game of Thrones thing, which I won't comment on. This might be our friends in Seattle. I won't mention them by name, but this could be their package delivery system moving around. So I think there's a lot of interesting positive opportunity for transformation. There's some negative transformation that we should risk mitigate against. And I kind of want to talk a little bit about benefits, and then we'll close. So what we think of as a magic-verse destination within a smart city on top of these like future 5G computing infrastructures, we think it affects like energy and water sector, transportation, planning, entertainment, education. We also think there's a big impact on manufacturing and manufacturing logistics. Food can get really interesting, like how do I get food? Sitting in a restaurant, what do I do while I'm waiting? Imagine a restaurant where the waiter was bad. You could tag that waiter with like 1 star. You could leave information for your friends, like this is the great pizza place, like the Big Cheese. This is how you get there. Imagine the live stream of like 30 years of UM students in like something like the Big Cheese. And if your big brother or big sister went there, you could see them when they were there 10 years ago. So it's a lot of really things to do with food and space and restaurants. Media will be really revolutionized. General tech, like how does tech come together? Something like this where you might be designing IoT, someone else creates a signal system, a radio system, traffic systems. They kind of need to all talk to each other. And we think profound impacts on like the Citywide healthcare. Can you raise the entire bar for every citizen in a city? Really quickly, some propositions and a couple sectors, and then we'll close. So let's say for energy and water, you might have a need to make a resource visible. You might need to have visualization for the city operations, and you might need feedback by the people in the city to give to the people who govern the city what's going on. So you can have very actionable data visualization, not just see it passively, but action on it. You could have a lot of interesting remote monitoring. You could have interesting lighting systems that could provide cost savings across the whole city, because you could sense when lights are coming on and off in different ways and when people are there. So you only turn it on when there's these people there when they need it. For things like transportation, how do you have sustainable mobility? How do you visualize the traffic patterns of life throughout all kinds of day and events for city operations, and how do you optimize those things? And what's the interface for people who are coming and going from autonomous vehicles or semi-autonomous vehicles? So overall, you want to have much better efficiency. You don't want traffic jams, which probably means much better sensing and much better logistics and machine learning around how we manage patterning. How do we understand the impact of travel on the community? There are some communities in South Florida that someone just decided to put a highway in and destroyed some of those communities like 40, 50 years ago. How do we simulate that and then simulate the damage it might cause to that whole community and say maybe that's not a good idea? And then how do you have better economic impact as you have less time stuck in traffic doing stuff? So all these are really interesting topics. I just wanted to seed you guys here. And then things like urban planning, so like the 3D modeling and simulations, things you really want to do well. How do you take all this different data, whether it's from traffic, weather, wind flow, AI simulations, IoT, to change policy of how the city is governed? Like saying all that and looking at our current government who can't pass a bill, sorry for saying that out loud, makes me wonder about the future we're trying to build in just daily basic functions. But we should plow through that and be very hopeful that we should be using technology to get to better decision making, so we don't have these kind of gridlocks. How do you make the best rational, optimal decision for a place, and how can technology help take politics out of it and make the best rational quality of life and economic benefit for all the citizens? And that's where you start to go, should AI be part of governance? And that's where these kind of questions will lead. Because you've got so much complexity, can 5 people or 100 people actually understand what's going on? Or do they need AI assistance and all these system level things to help them understand what they're doing? So it's really better engagement and awareness of proposals and construction projects and how they impact everything around them, how they fit into an overall master plan, and how do you promote things like healthier living and better working environments in an urban area. And then on healthcare, I came from medtech. I think the interfaces between doctors and patients and the amount of data that you can usefully collect about someone's life. Usually go to the doctor, they got 5 minutes. Okay, you have bad knee surgery. Okay, we got to pull this out of you. I mean, they spend 2-3 minutes on you, but you could gather years or months of incredibly important biometric data through spatial computing and smart city design that could then be fed to a healthcare AI that could really analyze what's really going on with you before, during, and after whatever intervention. And I think that's incredibly important because the doctors just don't have the time. So we need to use technology to normalize and make democratic access to the best possible healthcare. So it sounds, when you're an architect, are you worried about all these things? I would say yes, because cities can become much more intelligent, comprehensive, places where all these different services of human life come together. And then I'll kind of end on this. Sorry, one more slide. The economics of amplified cities, the economics of what we think of as magic verse, is that you're bringing places to people, so the opportunities are like 10x, 100x, or 1000x amplified. Where if you're just physical, there's a finite set of opportunities. So if you're, like we were talking before, if you're an informal city, you've got very finite economic opportunities. If you were a magic-versed informal city, your economic opportunities increase substantially, maybe by hundreds or thousands of %. So the idea is the power of place gets amplified, and we see that very early on with the digital economy, just things like Amazon buying books. Think of an Amazon versus a physical bookstore. This is that on steroids for an entire city. So the extension of what they can propose externally with all the digital capabilities to other cities and people and bringing other people in could greatly change the economy, where right now you have a finite economy by the amount of people who live here, can come and go by train or airplane or something like that. you have much faster, lower friction ways to bring things in and out with a digital sort of spatial economy. I just want to end and thank the University of Miami for letting us talk today. And just to highlight, the current project we're working on is something we call Alexandria, which is to try to make Miami a hub, a hemispherical hub, for this kind of economic and technology development. So if you think about what this part of the world can do, from Latin America all the way up to Canada, and this part of the United States and outside the West Coast, there's some really interesting things we could do. And I think there's an opportunity for Miami and to sort of become leaders in this intersection between city design, AI, technology, and sort of these 5G infrastructure. So anyway, thank you, everybody.
We don't have actually a lot of time, but I'm wondering if you could take a couple of questions.
Sure.
Just a couple of questions.
So very short answer to what really is a very long answer. But I would say is one, we're trying to turn into a petri dish for testing a bunch of these things. But I would say a small focal project with probably the most advanced tech-friendly team in Miami is the good first step. Something that is small in scope and has a short duration, like 12 months, where you can get a quick win. Because what I just described is 5 or 10 years of planning and design and implementation, but you need something that has a really high impact win that you could show people who are less tech savvy, maybe less futuristic. Simple application, first step. So if you guys are interested, the Alexandria project's a great place to partner and do something at and then clone it in Miami.
Would your city partners be people that are in the business? Are you looking for tech people? Are you looking for data people within cities?
Yes. Yeah, it's yes. Yeah, one more? We got two. I guess you were first by half a second.
So, Louis Cornell, CTO of an AI company. A little bit more going down a similar track with more technical. How do you deal with the large I/O problem and the data storage and transport problem on something like blockchain?
So the large I/O problem, part of that is we're working really closely with some of the biggest telecommunication computing companies in the U.S. and outside the U.S. So part of the I/O with I would say where 5G is going, you're going to have variable massive data uploads. You can send terabytes of data super fast by saying I need to do this right now, and the whole system responds to you, and then you could punch that variable load. And I think that's super interesting, and we've been seeing background testing. It's very different from normal Wi-Fi and LTE. And then the mass amount of compute and storage, I think that's where players whether you're Google Compute or AWS are going to be putting different data centers in sort of these emerging cities. But it's also an opportunity for distributed grid kind of storage where there's SETI-like projects where the citizens might be able to store 20%. Edge computing might be able to store 20%, and then cloud might do 60%. We're actually, we're going pretty deep with that. But I think the big three, Google Compute, AWS, and Microsoft with Azure, clearly have tons of capability to store data. But I think the 5G variable surge of data and compute is not fully known yet, probably outside of some R&D, but it's super exciting, where you could just punch immense data super fast within seconds. And that capability wasn't available for us. So I think it changes the thoughts around how you do a city. Cool. Thank you, guys.